Hello everyone, it's Tom from coAdjoint here. This is the bonus video in the tutorial series called Under the Bonnet. I hope you enjoyed the tutorial series if you got to this far. If you didn't watch all the tutorials and are just watching this for interest, then hello as well. This video will be a lot more informal than the tutorial videos, which I scripted to make sure that the content was up to the standard that I wanted. Unfortunately, when you've written 5,000 words and done quite a few videos and things like that, there were a few errors in the previous video, but nothing too major, I think. I think a few buttons, I sort of said they said one thing when they actually didn't. But I hope that that's not a problem in your understanding of the tutorials anyway. So this video, I'm just going to be talking a little bit about the underlying concepts behind the software and how it actually works. I've mentioned a little bit of these, but I thought it would be more interested to go into a bit more detail for people who are interested. So, as I've mentioned a number of times in my videos, Orbit uses machine learning to do the classification process and to attribute sets of skills like we see here with classifications, which is what you actually train Orbit on, the things that you see sort of in this column here. And the particular machine learning algorithm I use is a support vector machine algorithm. So, for those of you who aren't aware of what machine learning is all about, it's basically a way of taking data and teaching a program to understand patterns in that data. That's not a particularly precise definition. I go into a little bit more detail in the user guide here, but that's basically what it's all about. It's about getting programs to understand patterns in data so that it can actually simulate the patterns themselves. And so that's very useful for games, I think, because we players use common patterns a lot, but it's not really something that's explored in a great detail in video games at the moment anyway. And I think there's a lot of potential for this idea of personalization. I think it's quite interesting. So for anyone who is interested in computer science or machine learning, then the actual implementation I use is a support vector machine, which this Unity SVM DLL is basically a C# port of the libsvm C library, with a few tweaks here and there. I've seen other C# implementations of support vector machines, but the most popular one, I can't remember its name, but it had a GNU license here, I think, and that was obviously not appropriate for selling commercial software. And so I actually rewrote my own, and also I found when I was actually using the C# implementation, the popular one, I think it's libsvm.net. Actually, now I remember. I found that actually performance-wise, it had a very high memory footprint, and it was doing some weird stuff with Unity. So I actually sort of optimized it a little bit with the uses of classes, because I find that Unity doesn't really like classes very well. It much prefers to deal with structures, which is a little bit naughty in terms of modern programming paradigms, but it worked out quite well in reducing the memory footprint of the software. So it uses support vector machines. If you aren't aware of what they are, then it doesn't really matter, because I just go through a little bit of actually what's going on in the training process and then call it a day. So what happens when you give it a classification for a particular training example, as we saw in a couple of the previous videos? What's happening with support vector machines is it's like you've got a two-dimensional sort of set of axes, and every example that you give, well, in this case it would be a three-dimensional set, but imagine it as just two-dimensional. So say we only had two skills here. It's basically putting that point into a region in this place. It's plotting this point, so 83,6 as a vector 2, if you're familiar with Unity. And then it uses that point, and it sort of collates all those together to work out what are the most important vectors in determining the differences between classes. So the way that the Orbit works, is that we have different classifications, and what the Unity SVM is doing is partitioning two-dimensional space or three-dimensional space or however many skills dimensional space into different bits or partitions, or classes, however you want to call them. And the way it determines those is by the most important ones, i.e. the vectors which are closest to the different borders. It's a bit more mathematical and difficult than that, but that's the concept behind it. So every time that you classify an example, that's being considered by Unity SVM to determine what the important vectors are. And the reason why we have this sort of two-stage process with the training and the testing is because usually when you're using machine learning algorithms, you have sort of your data which you generate yourselves, or you have a data source which has been classified, and that's effectively what you're doing here. And then you need your training sample to test how well, or your testing sample, sorry, to figure out how good it is at actually doing that job. And what happens when you do the build, so when you go to your library and you press generate runtime library from asset, when you're actually building to the Apotheosis build library, what's happening is it's storing all of the data and in a serialized form in the DLL. And what it actually does at runtime is, as soon as in your awake, so when you instantiate your orbit runtime classes, what happens is that it effectively sort of retrains a machine learning algorithm again from scratch. That's not necessarily the most efficient way to do it, but it was probably the simplest way. I could have just stored the support vectors if that means anything to you, but I didn't actually go about it that way. Because actually, no, that's not true. I couldn't have stored the support vectors. I think that would actually give me a slightly different training. So I had to train from the full training set. That's basically how it works behind the scenes. It all gets plugged into this Unity SVM, which then stores all of the training data in here. Also, one other step as well that I should remind you of is that when it's doing the building and you get this model prediction, I'm actually doing using a grid search algorithm as well. So there are a couple of parameters that are important when you're using support vector machines, especially I think it's mu support vector machines, mu SVMs, or maybe gamma SVMs, I can't remember now. It's been a while since I wrote the software, but there's a couple of parameters called C and gamma, which are important for basically getting good, accurate classifications. And because the training data set is quite small, it means that we can actually do the grid searching algorithm in a couple of seconds, as you see when you press the build button. So when you press that, when you finish training, that's what it does. It gets the best values. It does a grid search to find the best value of those parameters. So I'll quickly show you that actually. So this training example might not have done anything different from the defaults, but let's just take a look. So this is the player attacking network that we saw. And there's C. So C has been set to something different. Or maybe that's the default value, I can't remember. And where's the init? So model. So this is actually all the training data being read in, which is kind of inefficient, but it works. And then has gamma been changed? Nope, gamma has not been changed. So that means that gamma here has just been set to 0. So the grid search actually came up with just a different value of C and the default value of gamma. So yeah, that's basically how everything works in Orbit. I hope this tutorial series has been interesting to you. If you have any questions, then please feel free to send me an email, and look forward to seeing some more videos and speaking to you all soon. Cheers, bye.